Hey weirdos, we're back. We're gonna sketch a curve again. You know what I mean? Anybody else getting stir crazy? Starting to lose my shit, being inside a lot. Huh? Like I said, let's get weird. So let's sketch the curve represented by x equals t plus its reciprocal, t plus 1 over t. Y is t minus 1 over t, and then we're just gonna look at positive values of t. No zeros, right? That wouldn't be in the domain anyway. Um, Oh, well, let's get after it. Now, this is not easy. This one's like I found this in a textbook and went, holy shit! Let's give love to the textbook. Yeah, it's Thomas's calculus. All right, found this one some old textbook. I thought this one was super neat. Now, in order for us to do this is going to be kind of tough to be able to just kind of solve and plug in, huh? That might not be. Yeah. So let's just get after this thing. And there's a little trick. So first, I don't know, do you mind if we just look at, can we just figure out what x plus y is? Just put it together. So instead of writing an x, I'm going to write in t plus 1 over t. So there's x. And now we're going to add it to our y, which is t minus 1 over t. And as we look through, we can see that, well, those will just cancel out. And we find out that x plus y is just equal to 2t. Frickin' fascinating, huh? Fascinating. All right, next one. Let's look at what x minus y is. Now, this one we need to be a little bit more comfortable, or a little bit more careful with. You know what I mean? Maybe the use of some parentheses in here. So we're going to do x minus y. So t plus 1 over t and t minus 1 over t. And let's put all our parentheses through this thing, and it's t plus 1 over t minus t plus 1 over t. Therefore, this time we're going to lose just the t's, and we're going to find out that x minus y is actually equal to 1 over t's, or 2 over t. Phenomenal. So what do we know? We know x plus y, we know x minus y. X plus y, x minus y. X plus y, x minus y. That sounds familiar. Sounds like something we've done before. Oh shit, that's a difference of squares, isn't it? That is a difference of squares. Huh. Well, let's see what's up. So let's go x plus y times x minus y. Remember that difference of squares? That this thing is equal to... well, let's look. Let's write it in. That's 2t times 2 over t, and the t's are just going to cancel out, and we're going to find out that wait a second, that difference of squares, x squared minus y squared, is actually just equal to 4. Oh shoot, we just took this and turned it all into x's and y's. We got rid of all the values of t. You would have clearly seen how to do that one, right? Oh yeah, me too. I just came up with this one off the top of my head. This one is aft. You know what I mean? Tough, probably not the easiest thing in the world to see, but this is where they can go. So get your practice so you start recognizing these patterns, because once you see as many patterns as possible, it's going to be a lot rougher to try and trick you on stuff. So that's really, we're just trying to catch as many patterns as we can get. But we haven't graphed this thing, so I already kind of have it graphed up. Do y'all know what this thing is? If you have any idea what this is, do you remember back to your conic sections? This is a hyperbola with its transverse axis being the x-axis. It means it looks like two parabolas on its sides going 2 different directions. Typically. Yeah, it doesn't quite work that way because we have our domain restriction at the beginning with our t is greater than 0. So we're actually not going to end up with anything over on the other side of our graph with this. So we're only going to have the right side. So I have it, some shitty graph right down here. Here it is. Here's x squared minus y squared is equal to 4 in just the right-hand side, not having the left because we had our domain restriction to begin with. Now there's the graph with it going off to, we're taking off to places. We're doing things. But let's think about this thing as to where it might begin. Now, I I believe that this down at the bottom should be gone. Now our original functions, we have that our x is equal to, oops, let's make sure to get that in. Our x is equal to, and that's a t plus 1 over t. And then our y is equal to t minus 1 over t. So let's plug in a real small value of t. Like t is equal to 0 0.1. What I mean? So when we plug that in, our x value, I'll let you hear, that's going to be 10.1. All right, and our y value is going to be negative 9.9. I'll let you look at that and figure that out on your own. But here's going to be where t is 0.1. Now I don't know exactly where this thing's going to start. You know what I mean? That thing's going to take off. So here's just this part. I'm just showing you right now what's going to be in here. I'm not actually going to show you the whole dang thing because it's going to take off and get really, really big, and I believe it's going to go all the way off to infinity. But we'll just keep on rolling through this thing. So there's a starting point. I think we're probably going to head in this direction. Let's plug in t is equal to, I don't know, this time let's put in 10. Let's just put in 10. And this time when we put in 10, we're going to end up with, I think now, we're going to end up with 0 0.1. Oh, there we go. It's going to be 10.1, comma 9.9. Oh, so there was our other value when t was equal to 10, right along here, where we have that this would be our 10.1. Right up here would be 9.9. Down here would be negative 9.9. So we see that we're going to end up there. But how about right in the middle? Some number that's going to work out nice, like t equals 1. Now that should be right up here in the middle. Now that's going to become 1 plus 1 is 2, and 1 minus 1 is 0. So we get 2 comma 0, and that was the point right here. So that was right there at 2 comma 0. But that's where t is equal to 1. This point here was where t was equal to 10, so we can see it's taken off, but as we take the limit, we let that thing get closer and closer. We actually do have the entire graph goes like this. So it's coming in this way, actually. So I don't even want to draw the arrow the other way. And there we be. Whoa, huh? Parametric equation. So this is our last example as to how we play around with them. We plug them in and we do stuff. So we're going to be back at it in 10.2. 10.2, now we're going to start doing some calculus. This 10.1 was a review, just making sure that if you might have forgot something from trigonometry or pre-calculus, or maybe you had a teacher like me that just didn't seem to cover the parametric equations, and that's not your fault. Well, here's your opportunity. 10.1 is a little bit of an algebra review. So jump on into it, take advantage of the fact you're not doing calculus for at least one section, and then we'll be back in 10.2 to kick your ass with some integration and derivatives and shit like that.